Hello, everyone. My name is Shelby, and today we're going to be learning about water. And we're going to be learning about water from the California Water Institute, which is super cool. So, I just said we're going to learn about water, but we're also going to learn about specifically, we're going to learn about water where we live, right here in the Central Valley. So, in the Central Valley, we use water to farm because we have to grow our own food and everything, and we probably drive around a lot, and maybe you've driven by Fresno State and seen our farm and all the wineries around. So we use water on farms. We also use water to treat in water treatment plants for just use for drinking water and stuff like that. And water also goes towards the rivers, which, as everyone knows, goes to the ocean. So what happens to all of the unused water? Well, that is where we come in with the water cycle. And this image is going to look a little bit familiar. You might have seen it on a little pamphlet in your package of supplies. So we're going to use this a little bit later, but right now I'm just going to talk about it a little bit. So first, we get a lot of our water from rain. And this part over here is the precipitation. And that's what rain is. Rain is precipitation. And then any water that doesn't soak into the ground is going to evaporate back up into the clouds, and then it's going to rain again. And so that's how we have a water cycle. It goes in a big circle. And so it goes evaporation, condensation, and precipitation. And that's how we have water on the surface. So there's two kinds of water sources. One is surface water. Now, how do you tell if it's surface water? Well, ask yourself this question. Can you see it? If you can see it with your eyes, that means it's surface water. So surface water can be snow, it can be rain, and it can also be lakes, and it collects in rivers and canals, and it can be used on a farm to water crops. So that's kind of what it looks like. That's a canal around in Fresno, which you might. The second type of water source is groundwater. Now, groundwater is any water underground that we can't see. If you can't see it, it's groundwater. And if it's underground, then how do we use it? That's a pretty good question to ask. You have to use a well to pump it from the ground. And wells often look a lot like this. And some of us might have wells in our backyards that we use to pump water up from the ground. All right, so next we're going to talk about efficient irrigation on farms. And this can happen three major ways. So the first one is sprinklers, and the second is drip irrigation, and the third is center pivots. So we're going to talk about sprinklers first. Now, sprinklers you might be familiar with because you might have them on your lawn in your front yard or in your backyard. And they can be really big or they can be really small. So some of them can be used to water sports fields like shown here, or our crops, and these are a little bit bigger, or they could be used on your own lawn at home, which would probably be small ones. Second is drip irrigation, which can be above or below the ground, and it's basically spaced apart with the trees or plants that are in that area. So they also have, it can be in the form look like this, which is where they all meet together, and then they will all kind of look like this, and it'll drip the water throughout. It might be on a timer or something like that, and it'll give the plant exactly the amount of water that it needs, which is super important. So the third method of efficient irrigation is called center pivots. Now, these are a sprinkler system that are tied to a center point. So what I want to show you here, these are important because it's less equipment is needed for this method. And what happens is a lot of the time you get these really interesting circular looking fields. So if you see this one over here, it's a really big circle. And that's because, and I'll show you a little example here. So I have a rubber band and a pencil and a pen. So what I'm going to do is the pen is going to be our fixed center point. So that's where, the middle, and the rubber band is going to represent our sprinkler system. And so the pencil is going to go around, and this is the wheel on the outside of our center pivot, and they just go in around in a circle. And eventually you have a big circular field. And so that's kind of how it works in a sense. Get the gist? Okay. So, and it takes a lot less equipment to move, which is really nice for farmers. So What do all of these methods have in common? Well, they give all the plants exactly the amount of water that they need, because we really don't want to overwater our plants, because then less water is wasted and we have more water to be able to drink and use that's nice and clean. So now we're going to talk about groundwater recharge. Groundwater recharge is a process where extra water on the surface that isn't used goes back into the ground to recharge our groundwater supply. So as you can see by this diagram here, the water is going to go down through the earth and it's going to settle underneath our surface, which is going to be important. And then we're going to use wells to pump it back out. So we're going to use a well to pump it back out from under the surface because it's under the ground. It's a groundwater. Remember, we can't see it. So how can water be contaminated? Now we're going to talk about water contamination, which is super important. So it can be contaminated naturally or unnaturally. Naturally meaning things that just occur, that are naturally occurring in our environment. So, natural elements and things that we can't really control. Unnaturally meaning things that we as humans do. So what happens after it's contaminated? Well, it has to be treated in a water treatment plant, which uses energy. So how can we prevent water contamination? Well, we can know exactly the amount of soil and fertilizer that our plants need. So we're not using excess fertilizer, because fertilizer has chemicals and things in it that when added, when the plant doesn't use enough of it, it can seep down into our groundwater supply and contaminate our groundwater. So it's super important that we know exactly how much fertilizer our plants need to survive. So thank you for listening today. Hopefully you learned something really awesome about water. And next in our little module here, we're going to do a groundwater contamination activity. So we're actually going to see exactly how our groundwater can be contaminated super easily. So I will see you in the next video. Hey guys, what's up? Welcome back to part 2 of our water module. Today we're going to be doing like a fun little science experiment. So hopefully you guys enjoy. So what you're going to need for this experiment is your already prepared supply bag, courtesy of California Water Institute. And then you're also going to need a pair of scissors, and I'm going to show you why in a second. So when you open up your bag, you should have a little water bottle here. So we could set that aside for now. And you should have a cup full of dirt and rocks and things. And then you're also going to have this little reading pamphlet, which we're going to get to next. Okay, so you can just set that right on aside. So the first thing we're going to do is you want to take your bag of rocks. See the rocks? They look like this, rocks. And you want to pour them into your cup. Now you want to be really careful because your mom will get mad at you if you make a mess. Okay, so you want to be super careful and pour the rocks into your cup. Now, once you're done, you don't need the bag and you just got a little layer of rocks. Then what we're going to do is we're going to take our bag of dirt and we're also going to pour it. And it goes again without saying, if you spill it, your mom's going to be really mad at you. So I wouldn't spill it if I were you. Okay. So we poured our rocks or our dirt in and our rocks. So see, we have a layer of rocks and we also have a layer of dirt. All right. Now, this is a very important step. I need you to listen very closely. All right. So do you see this red dye right here? This will not taste very good. So don't do this at home. Don't do it. Don't take your mouth and bite this corner. What we're going to do is we're going to take our scissors and we're going to cut the other side. So see how this side has the red? We're going to cut this side off just a little bit. We're going to snip it off, and then we're going to be really careful and we're going to let this food coloring drop right in the corner, one corner of our experiment. So I'm going to show you in a second. This stuff will make a big mess. So if you see, there's just food coloring in this corner right here. That's all we want. Okay. So what this is going to demonstrate is the rocks and the dirt are going to represent our earth, and we're going to pour in water that's going to represent our groundwater. And we're going to represent how just a little teeny tiny bit of something can totally contaminate our water. So maybe if you want to put this into real life, maybe think about the food coloring as gas. So underground, there's a lot of gas tanks, when we go fill up our cars at the gas station. And so maybe there's a hole in the gas tank. And so that's kind of what this will represent. It can be a lot of other things too. So just think about it. So now we're going to use our water. We're going to use our water and we're going to open it. And if you have to ask for help, pause the video. I think we should hopefully be able to open water. Now what we're gonna do is we're gonna pour our water into our cup, and you just wanna pour the whole thing. Now, what I want you to see, what I want you to notice is how quickly that water turned red, but also, do you see how it's getting into the bottom part of the cup and all of our dirt? That's what happens when it gets into our groundwater. And you see how it's all the way down at the bottom. And if you let this sit for a little bit and you don't spill it and you don't make a mess because your mom will be mad at you, you can see how much the water's getting into the dirt. Do you see that and how much it's going around? And pretty soon, in a couple seconds, it will all be contaminated. So that's why we want to be super duper careful about how much fertilizer we use for our plants. And also, we want to be super conscious about the things we're leading to our water source. Because look at that. Imagine if our water looked like that. That would not be fun. All right. So I hope you guys enjoyed being able to see what happens when water gets contaminated. And stay tuned for the next part of our module, which we're going to do this really fun reading vocabulary activity that has a really fun crossword puzzle on the back. So hopefully you guys like that. Hey guys, welcome back for part 3 of our water module for today. So what you're going to need for this part is this pamphlet, which should be in your bag full of goodies. And it also has a pencil. And so what you're going to need right now, I'm going to play a video and it's going to show you all around this map. And some of these places might look familiar to you, which would be really, really awesome. Like I think I see Millerton and I see Fresno State and all that kind of stuff. So that should be really, really fun. And they're going to take you through all of the reading.
The water cycle in our neighborhood watershed. The water cycle moves water around our planet and through our watershed. Our watershed is where we get our water. Each winter, precipitation falls as snow in the Sierra Nevada mountains and creates the Sierra Snowpack, which is stored during the winter. Beginning in the spring and lasting into the summer, the Sierra Snowpack melts and flows down the mountains into the San Joaquin River and the Kings River. Some of this water is used for agriculture, which is the San Joaquin Valley's #1 industry. Water from the rain or urban runoff goes into the storm drain system, where it flows through a system of underground pipes to one of our pond basins throughout our community. At the pond basin, the water slowly soaks into the ground and into our groundwater aquifer. Our drinking water is stored below ground in a natural basin called a groundwater aquifer. 90% of all the water we use is pumped up from the groundwater aquifer and delivered to our homes, schools, and businesses. Using hundreds of wells, about 146 million gallons of water per day is pumped out of the aquifer. In addition, 10% of our water comes from the Sierra Snowpack. All of the water we use in our homes travels 4 miles through the sanitary sewer to our regional wastewater reclamation facility. The water is treated and reclaimed and/or recycled so it can be reused. In the primary treatment, paper and plastics are removed in the headwork grit removal sand. In the secondary treatment, organic materials are removed using bacteria that multiply as they eat organic waste from the water. Clarifiers are used to separate the bacteria from the water. The bacteria are then put into an anaerobic tank where digesters break it down, and the energy is extracted and converted into electricity. Last, the reclaimed water is sent out into evaporation ponds and is recycled for reuse to irrigate golf courses, cities, private landscapes, and areas throughout our community. The reclaimed and/or recycled water is known as the Purple Program.
So I hope you enjoyed reading about our Central Valley and the water cycle. If you want, there's a fun crossword puzzle in the back, and we even gave you a pencil so you can fill that out however you like. And I hope you enjoyed learning with us today and have an awesome summer.